So first one you can check what is osmosis. What is osmosis? Osmosis is nothing but the flow of solvent particles through a semi-permeable membrane from low concentration to the high concentrated solution. Low concentrated solvent here, you should mention. Low concentrated to the high concentrated solution. Okay, what is osmosis? Osmosis is nothing but flow of solvent particles from low concentration. CON means concentration. Okay, low concentration to the high concentrated solution through a semi-permeable membrane. Through a semi-permeable membrane. Semi-permeable membrane. Okay, listen here. Semi-permeable membrane is nothing but it can allow only selected particles, not all particles. Semi-permeable membrane allows selected particles only. Semi-permeable membrane SPM. You can use short word here. Semi-permeable membrane SPM allows only selected particles. Okay, allows only selected particles. So you can take example for semi-permeable membrane, that is parchment membrane. Okay, parchment membrane. I will explain you by taking one diagram. Okay, you will understand better. And also cellophane. Okay, etc. Cellophane is the synthetic one. Okay, parchment membrane is the natural one. Okay, osmosis is nothing but flow of solvent particles from low concentration to the high concentrated solution through a semi-permeable membrane is known as osmosis. Here, suppose you can take, just try to understand this diagram. This is one glassware. Okay, here this glassware or beaker divided into two equal halves. See, this is what, my dear, semi-permeable membrane. This is what? Semi-permeable membrane. Here, one side of this glass vessel, solution is there. Solution. One side of this glass vessel, solution is there. This is the solution. You already know solution made up of with the solvent plus solute. So you can say directly it is a solution. So you can say it is a solution. So in this solution, solution is made up of its solvent and solute. So here, see, these are the solute particles. These are what solute particles are present in solution. So you already know solvent plus solution, solute is known as the solution. See, these are all solute particles. Clear, all of you, what I am saying to you? If you have doubt, you can message me, okay? Yes. And then this side you are going to take pure solvent. It is what? Pure solvent. This pure solvent also has minute amount of solute particles, minute amount. But this is the pure solvent only. This is the pure solvent only. Pure solvent. What is it? Pure solvent. Pure solvent. Here solvent is water. Just here. Let's take an example. It is water. So here solvent is water and solute is salt. Okay, solute is what? Salt. So what will happen here? What I told you in this definition, the flow of solvent particles from low concentration to the high concentrated solution. Here, remember, my dears, low concentration indicates about concentration of the solute, not about solvent, concentration of the solute. And also high concentration indicates about, this is also concentration of the solute only, concentration of the solute, and low concentration of the solute. It is, I mean, this one is applicable for pure solvent, and this one is applicable for solution. So what I am saying here, the solute particles are minute amount only present in the pure solvent. That's what the solvent having less concentration. That's what the solvent is going to move from low concentration to the higher concentration. So here, try to understand. See this side. From left to right, solvent particles going to be transferred. From left to right, solvent particles going to be transferred. So up to up to which condition? That means to attain equilibrium condition. That means the solute concentration should be equal, left side and right side. That means pure solvent and also solution. Understand what I am saying? So you can observe this diagram also. You can able to understand easily after seeing this. See, this is the semi-permeable membrane. Semi-permeable membrane. So here, pure solvent concentration would be decreases. Nothing, concentration, especially here, volume would be decreases because the solvent particles transferred from low concentration to the high concentration. So, this is the solution. This is what? Solution. And then at this time, this one also a solution. So, here, solute particles concentration would be increase and solvent particles concentration would be decreases. Here, see, this is solvent and solute. This is solvent and solute. This is known as what, my dears? Osmosis. This is known as what? Osmosis. What I told you, the osmosis process happening up to attain equilibrium state. To attain equilibrium state. So, from this diagram to this diagram, if you observe, this is the equilibrium state. This is what? Equilibrium state. Understand all of you what I am saying? One more time. Flow of solvent particles from low concentrated solvent to the high concentrated solution through a semi-permeable membrane. This process happening to attain equilibrium state in solutions. Here, especially semi-permeable membranes, we are going to take, that is parchment membrane and also cellophane. Here, if you take example, this is pure. Here it is. See, this is pure solvent. This is water. Okay, and right side of this this glass beaker, water and salt. This is known as a solution. So the solvent particles moves from left to right. That means low concentrated place to the high concentrated solution. Understand? After some time, the equilibrium should be attained. See here, solute particles would be increases. Here, solvent would be increases. So here dilution increases. Here concentration would be increases. So this process is known as osmosis. This process is known as osmosis. Please note all of you. Dear students, up to this one, any one of you have any doubt, please let me know. Okay. If possible, you can take screenshot. If possible, you can take a screenshot. I'm going to move next page. Is it finished? Is it finished? All of you? Can we move to next page? Good girl. Yes, thank you, Akanksha. Okay, I'm going to next page. Yes. So, next you can check osmotic pressure. What do you mean by osmotic pressure? Osmotic pressure. This osmotic pressure indicates with the letter pi. Okay. Yes. Osmotic pressure is known as the force or pressure applied refers to the process osmosis. Understand what I'm saying? Osmotic pressure. OP I'm writing here. Okay. Osmotic pressure is the force applied in opposite direction to the osmosis. Especially we are using this osmotic pressure to stop osmosis. Understand all of you? Yes, osmotic pressure is nothing but the force applied in opposite direction to the osmosis is known as osmotic pressure. Especially we are using this osmotic pressure to stop osmosis. Clear? So if you check diagram here, you can understand better. See here, this is the semi-permeable membrane. This is the semi-permeable membrane. This is the pure solvent. This is the pure solvent. This is the solution. This is what? Solution. In solution, solute particles also there. Okay, here only few particles are there. Okay, so what I told you, what is osmosis? Flow of pure solvent from low concentration to high concentration. If the process is going to be continue, then that means equilibrium should, I mean, after attaining equilibrium also, if the process is going to be continue, is it, I mean, the concentration from one side of the solvent and the concentration one side of the solution would become unequal. That's what at that time we are going to apply external pressure. We are going to apply external pressure. Here, see, PATM, atmospheric pressure, along with this osmotic pressure. This is C. This is pi is what osmotic pressure. Here only P atmospheric, nothing but atmospheric pressure we are applying here. Here we are applying both atmospheric pressure along with the osmotic pressure. So what will happen? The osmosis process going to be stopped after attaining equilibrium. Okay. So if you go to check its properties, osmotic pressure is colgative property. Okay, colgative property. Osmotic pressure is the colgative property. It is directly proportional to the concentration of the solution. Okay, it is directly proportional to the concentration. It is directly proportional to the concentration of the solution at a given temperature. At a given temperature. Listen. So, if you remove this proportionality, pi equal to R CT. See, I already mentioned at a given temperature. So, you should mention here temperature. And pi equal to R N by V T. What I told you, concentration at the concentration of a solution at a given temperature. Here, concentration maybe you can use CR, maybe molarity, not molality. It is molarity. Understand? It is molarity, not molality. It is molarity. Clear? So you can write instead of C, you can write M also, or maybe you can write C. So here, especially pi equal to R N2 by V into T. Pi equal to R N2 by V into T. Listen, here N2 is nothing but number of moles of solute. Number of moles of solute. So, number of moles equal to what? Weight upon molar mass. So, you can substitute. Pi equal to W2 upon M2 into RT upon V also their volume. Clear all of you? W2 is nothing but what? Weight of solute. Clear? Next. Capital M is nothing but what? I'm going to next page because it is congested. So I'm going to next page. See here, I'm writing. Capital M is nothing but what? Molar mass of solute. Molar mass of solute. And here capital M2 you can mention because solute. And also next one, R is what? Gas constant. Gas constant. I will go to next page, don't worry, okay? Gas constant. T is the given temperature. Given temperature. Pi is what? Osmotic pressure. Phi is what? Osmotic pressure. Clear, all of you? Yes. So previous page you can check. So please note, all of you, we have only 9 minutes time to finish this session. So please note each and everything what I am saying to you. Any one of you have doubt? Can I move next page? Next page, is it okay, all of you? Yes, thank you, Sindhu. I'm going to next page. If possible, you can take screenshot. It is easy to write later, okay? Yes. Listen, this is about osmosis and osmotic pressure. And then one more important point is here. Solutions which are having same osmotic pressure. Solutions which are having same osmotic pressure are known as isotonic solutions. Isotonic solutions. Isotonic solutions. If solution here, how can you identify isotonic solutions? The isotonic solutions concentration is 0.9 percentage weight by volume is there. If the solution concentration is 0.9 weight by volume, then that is the isotonic solution. Here, there was no osmosis process. Understand, there was no osmosis process for isotonic solutions. Example, you can take blood. Okay. Yes. Next one, the solutions which are having less concentration than, that means the solution concentration is less than 0.9 weight by volume concentration, then that is what, all of you, hypotonic solutions. If solution concentration is, here solution you can write, okay. If solution concentration is greater than 0.9 percentage weight by volume, that is what, hypertonic solution. Hypertonic solution. So suppose if you take 1 molar glucose is isotonic to the 1 molar fructose. This is okay. Next example, if you check next example. Solutions which are having low concentration than 0.9, I told you, hypotonic, and if they are having a high concentration than 0.9, their concentration would be, I mean, those solutions are known as hypertonic solutions. Suppose you can take 1 molar glucose and 2 molar glucose and 3 molar glucose. If you compare these three, here 1 molar glucose is hypotonic or hypotonic than 2 molar. Clear all of you? 2 molar and 3 molar. Yes. 2 molar and 3 molar are hypertonic to the hypertonic to the 1 molar glucose. Clear all of you? Clear all of you? Yes. Please note all of you. And one few examples we can see about osmosis process. If you take mango or mango pieces, if you kept mango pieces in a brine solution is nothing but what? NaCl solution. Brine solution is nothing but NaCl solution. If you keep mango pieces in NaCl solution or nothing but brine solution, what will happen? The mango pieces size would become less. The mango pieces size would become less because the water present in mango or mango pieces going to be come out. Understand? Because inside of the mango water concentration is more, so that water we are going to imagine that is pure solvent and salt concentration would be less. That's what the water present inside of the mango comes out to the brine solution, because brine solution is a highly concentrated solution when compared to the solvent present in the mango. That's what here mango pieces size would become less. Size would become less because of the water present inside of the mango or mango pieces would become enters into the brine solution. And also if you take flowers or leaves, if you spray water droplets on flowers or leaves, they are going to absorb this water and then they will become fresh or not. Yes, that is also one type of osmosis process. Yes, my dears, this is about osmosis and osmotic pressure. If you have any doubt, we have 1 minute 52 seconds, so you can ask me. You are nothing but you can type in your chat box, then I will reply to you. If you want previous pages, then I will show those pages also. First, let me know this page is completed or not. Is it completed? This page is completed, everyone. Good girls, you are giving reply to me. Sindhu, yes. Yes, ma'am, completed. Akanksha, yes, very good, all of you. Yes, I'm going to previous page. This is previous page, osmotic pressure. Finish this page also. Yes, I'm going to first page. This is osmosis. So only 1 minute is there. If you want to talk with me, I will give you access to talk with me. If you want or not, just let me know. Completed. Very good, Deepika, Akanksha, Sindhu. So please, tomorrow and day after tomorrow also, maybe we will have same timing. So please inform to your friends to join chemistry class. Okay, then we will have some interaction with each other and we will learn together. Clear, all of you? Is it understand or not? All of you, just let me know that one also. Any doubt? You can type.